All right. So next up, what we have is half-lives. Last class we looked at doubling times. Now we're going the opposite way, and half-life is exactly well, the words are right there. Is the required amount of time that it takes a quantity, again, which is something you can count, anything you can count, to cut to half its original size. It's like doubling times was a particular type of exponential growth equation. Well, this is a particular type of exponential decay. Some of the applications, the most common ones, are the rate of reduction of a bacteria culture or virus. So it's one way to indicate how well your medicine is working. If you have, say, some antibiotics, how fast it's cutting the bacteria in half in your body. A big application that's used is the decay of radioactive material. So it's another big thing. Now, again, we have a couple of formulas, just like we did before, and they are going to look very, very similar. Because the first thing is, when you're looking at the half-life of something, of a quantity, which again, I'm just going to use a big capital H to represent it. Well, you were going to take the time elapsed, and I'm going to divide it by the number of times the quantity that you were talking about halved. Oh, that's almost identical to our doubling times, or doubling time formula. Only instead of number of times the quantity doubled, we're looking at the number of times the quantity halved. Now, our other formula, just like we had before, we're going to have n is equal to n naught, looks familiar, times, this time though, we're looking at half-lives, 50%, or as a decimal, I can have a 0.5 in here this time. And the exponent is also going to be a fraction where we have t, this time divided by h. So it's almost the identical formula we had before, where again, n is our final amount. Our n naught, if you will, is our starting amount. Those are the same. T is the same as where we have our time elapsed. And then lastly, h is our half-life of whatever we're talking about. There we go. And of course, the 0.5 there is a little bit different because we're talking about half-lives, not doubling times. All right, so we're going to, well, use these formulas. Let's try an example. Again, just like before. Number one, there is 200 grams of radon, which is a radioactive material. And 12 days later, there is only 12.5 grams. What is the half-life of radon? So again, I've got my formula where we have H is equal to our time elapsed. I'm just going to put a T there, divided by the number of times this radon cut in half. Got to watch myself there. Number of times radon halved. That's weird. All right, so now I'm going to do what I did before over here in the corner. I'm going to figure out how many times it halves. So it's going to look a little bit different because I'm not doubling as I go down, I'm halving. So I start off with 200 grams. Well, then I am going to cut in half to 100, cut that in half to 50, cut that in half to 25, and then I cut it in half and I get my 12.5. All right, so now I look and let's see here. It cut in half once, twice, 3 times, 4 times that happened. So cut in half 4 times. That took 12 days for that to happen. So that is my time that's gone by. And so I get my half-life to be, well, 12 divided by 4, and we're in days. It looks like it takes 3 days for this material to cut in half. Okay. We get to B. How much radon is left after 18 days? All right, well, 18 days divided by 3 is a nice number. So I can do this, I guess, the chart way, the straightforward way, where I, again, got my starting amount, and I'm starting off with 200 grams. But then after Day 3, I cut in half. I'm down to 100. Whoops, 100. Then 3 more days goes by, so I'm on day 6. I'm down to 50. Then 3 more days goes by, I'm on day 9. I'm at 25. Let's see here. Yeah, all right, keep her going. 3 more days, I get to day 12. I'm at my 12.5. All right, I'm going to keep going here. Let's see here. That 3 more days gets me to day 15. I take 12 and a half and I cut it in half. I get 6.25. And then finally, 3 more days later on day 18, I cut my 6.25 in half and I get 3 points, again, rounded 2 decimal places here, 13 grams. And there we go. So after 18 days, we got 3.13 grams of radon left. Now I get to see how much radon is left after 19 and a half days. Well, 19 and a half divided by 3 is not a nice number. So I am going to have to use my formula. So I have my N is equal to N naught. We're dealing with half-life, so it's times 0.5, half. And I have my T divided by my H. All right, so the values I have, let's see here. And we're trying to figure out how much is going to be left. I know it's going to be less than 3.13 grams because that's how much was left after 18 days. So it's got to be less than that. We started off with 200 grams, so there's my N naught. Time that's gone by, 19.5 days. We already figured out the half-life of radon is 3 days. All right, so there is all our information we need. So now it's time to substitute in. All right, so I have my N is equal to my N naught. We start off with 200 grams times, we have our 0.5 here in brackets. And then my exponent, I'm going to have 19.5 divided by 3. Okay. All right. So, well, before I can even do some calculating, I got to figure out what that exponent actually is. So I got N is equal to 200. I got my 0.5. All right. So let's figure out the exponent. I take 19.5. And I divide it by 3, and I get 6.5. All right, now to do my bedmas. Let's see, let's make it bigger. There we go. N is equal to, we got the 200. Now I'm going to take that 0.5 to the power of 6.5. And I'm going to get 0.0, let's see, get a few numbers in there, 11. All right. And then finally, I'm going to multiply those two numbers. So we got my 200 times my 0.011. And I just get simply 2.2 grams, which again is lower than the 3.13, which I expected because we're still losing some radon there. So again, very similar to our doubling times formula. Works exactly the same way, except for inside our brackets here, we have a 0.5. But again, the formulas are much the same and work much the same, except for when you're doing it the straightforward way, we are cutting in half rather than doubling. All right, so that is it for our